Trigonometric ratios, quadrants and angles. Here is question number 3 for you. The coordinates of a point on the terminal arm are shown. Determine the exact trigonometric ratios and the angle. Well, you can find angle to one decimal place. Okay. Now that is the terminal arm. We'll write this as O. So OR is our terminal arm. So the angle which we are interested in is principal angle measured from positive x-axis as shown here, correct? So that is the angle we are really interested in finding, right? Now let's first find out the angle. To find the angle, what we do is, whenever this arm is given to us, drop a perpendicular on the horizontal line, which is x-axis. So let me just make this triangle. Correct? And now this triangle will give us one angle, which is this. We'll call this angle as alpha. So this angle in every quadrant will be an acute angle, correct? And our answer is the principal angle we are looking for, and that angle we'll call as theta. Correct? So that is the angle which we are looking for. But first we should always find the related acute angle. Related acute angle is the angle which terminal arm makes with the horizontal. So that is this. And now we have our triangle in which we can find tan theta and thereby the angle alpha. Correct? Always when you are given a quadrant like this, ordered pair 2 minus 5. That means x value is 2. So this is the x value and y value is minus 5. There it is, going downwards, right? Now, forget about the sign for the time being and think about angle alpha, right? Now, so what is tan theta? Rather, tan of alpha. So tan of alpha for us will be opposite over adjacent. Opposite sign is always the y value, which is, we'll take positive 5, and x value 2. So consider as if this triangle is in quadrant 1. Think like that. And we are just trying to find angle alpha, okay? Now use your calculator to find tan inverse. So we have alpha equals to tan inverse of 5 over 2, correct? So we do tan inverse of 5 over 2 is equal to, we get 68.19. So that is equal to 68.19. So let me write down here 68.19, right? You can round your answer to one decimal place and let it be 68.2 degrees. So this is my angle alpha, right? So that is my related acute angle. We will always assume this triangle to be in quadrant 1 and always take these values positive. Okay, let that be a rule. Okay, now what is the angle theta? Theta will be 360 minus alpha, correct? So that is what our angle is. So primary angle or principal angle is theta, which is equals to 360. 360 is full circle, correct? Minus 68.2. Is it okay? That is our answers. 360 minus 68.2. So let's do that. So we'll do 360 minus 68.2 and you get 291.8. So that is equals to 291.8 degrees, correct? So that is your answer for the angle, correct? I hope you understand. Let me push it a bit in front so that it's absolutely clear to you, right? So that is your principal angle which we are looking forward to. Now let's find out all trigonometric ratios. Well, quadrant, you know, we are in quadrant 4, right? This is quadrant 1. This is quadrant 2 for us. This is quadrant 3. And that is quadrant 4. Correct? So we are in quadrant 4. Now, you also know the cost rule. Correct? Cost rule is cos is positive here. Right? So we'll write C here. So let me write C, A, S, and T. Right? C is positive here, and all of the trigonometric ratios means sine and tan are negative. Correct? So let's figure out what the trigonometric ratios are for the point R, which is in quadrant 4, correct? So let's start with sine. So sine of theta, we'll write sine of theta, okay? Sine theta, theta which we just calculated is 291.8 degrees, okay? So sine theta is opposite, so you look from now this angle, correct? So opposite is this, which is minus 5 over hypotenuse. Now we need to find what hypotenuse is, right? So to find hypotenuse, we'll use Pythagorean theorem. So this is your perpendicular, correct? And so the hypotenuse, that means OR, is equal to 2 square plus 5 square square root. So let me do that. So let me write R, the radius of this is 2 square plus minus 5 square square root, correct? That is square root of 4 plus 25, and that gives us square root of 29. So when we are finding answers in exact trigonometric ratios, then we have to use square root 29. Okay, don't round them, don't use decimals. Okay. Now sine theta is opposite over hypotenuse. Opposite here is minus 5, and so we get minus 5 over square root 29. So that's the value of sine theta. Cos theta. Cos theta will be positive value. In this quadrant, cos is positive, right? That is also a check for you. And the positive value of the base, which is also the adjacent side over hypotenuse, right? So adjacent is 2, the x value, correct? So it is 2 over square root of 29. How about tan theta? Tan theta is ratio of these coordinates, right? Y over x minus 5 over 2. Correct? The other trigonometric ratios are reciprocal of these, correct? So what is the reciprocal of sine theta? Cosecant theta. So let's write down. So we have cosecant theta equals to, just flip it, square root of 29 over 5 with negative sign, correct? What is the reciprocal of cos theta? Secant theta. So secant theta is equals to square root of 29 over 2, correct? And cotangent theta is cot theta is equals to reciprocal of tan, which is minus 2 over 5. So that is how you get all your ratios, correct? So I hope you understand how to solve your questions which are related to this kind of a circle, a point given on the coordinate system. A point in general. So in general, so here is, let me summarize, general solution. Let's say a point is given and the point coordinates are x and y, correct? So you can find angle theta by theta equals to tan inverse of y over x, correct? Y over x. No need to take the sign negative positive. Forget about the sign. Since we are assuming that our point lies in quadrant 1 and we are only interested in finding the angle alpha. So let me not write theta here, acute angle alpha. That is better. Now, we know acute angle alpha, theta, the principal angle theta will be, you have to find where it is, right? If it is in quadrant 4, then it is 360 minus, right? If it is in quadrant 2 or some other quadrant, there will be 180 plus or minus. So in this case, general solution will be 360 degrees minus acute angle alpha, right? Now, and second thing which you have to always do is find the radius, right? So for radius, always write radius is equals to x square plus y square square root, correct? And for exact values, use this value of radius, correct? And you know what sine and cosine is. Sine of angle theta will be equal to y over r, and cos will be x over r. And how about tan? Tan, you know, is y over x, correct? Tan is y over x, correct? So that is how you are going to do solutions for such problems, and this is your general solution. Okay, I hope you understand. Thank you.